A Kafka topic is essentially a category or feed name to which records are published. Think of it as a channel where messages are sent and received. Each topic is identified by a unique name, and it can have multiple producers writing to it and multiple consumers reading from it. This design allows for a highly scalable and flexible messaging system. Now, let's break down its purpose. In the world of data streaming and message brokering, a Kafka topic serves as the backbone for real-time data processing. It allows different applications to communicate with each other seamlessly. For instance, imagine an e-commerce platform. When a user places an order, that event is published to a topic. Various services like inventory management, payment processing, and shipping can subscribe to that topic to react to the order in real time. This decouples the services, allowing them to evolve independently while still working together. How does it work? When a producer sends a message to a Kafka topic, that message is stored in a partition. Each topic can have multiple partitions, which helps distribute the load and allows for parallel processing. This means that multiple consumers can read from different partitions at the same time, enhancing performance and throughput. Kafka guarantees that messages within a partition are ordered, which is crucial for many applications that rely on the sequence of events. Another key aspect is durability. Kafka topics are designed to retain messages for a configurable amount of time, even after they have been consumed. This means that if a consumer goes down or needs to replay messages, it can do so without losing any data. This durability is achieved through replication. Each partition can be replicated across multiple brokers, ensuring that even if one broker fails, the data remains accessible. Now, let's talk about the role of Kafka topics in data streaming. In a streaming architecture, data flows continuously, and Kafka topics act as the channels for this flow. They enable real-time analytics and processing, allowing businesses to react to events as they happen. For example, a financial institution can monitor transactions in real time to detect fraud, or a social media platform can analyze user interactions to personalize content. Kafka topics also support a publish-subscribe model, which is incredibly powerful. Producers publish messages to a topic without needing to know who will consume them. Consumers can subscribe to one or more topics and process messages at their own pace. This flexibility allows for a wide range of applications, from simple event logging to complex event-driven architectures. In summary, Kafka topics are fundamental components of the Kafka ecosystem. They facilitate communication between different services, support real-time data processing, and ensure durability and scalability. By leveraging topics, organizations can build robust data pipelines that handle vast amounts of information efficiently, making Kafka a cornerstone of modern data streaming and message brokering.